So welcome back class 8th students in our chemistry class, and we are dealing with the same third chapter, elements, compounds and mixtures, and this is our lecture number 7. And today we are going to take two process of separation, and as all of you know, I think that we are dealing with soluble solid in a liquid and its separation. So soluble solid, if the solid particles are soluble in the water or in its solution, then how they will be separated. So we have seen last turn also, and this turn we are going to deal with distillation and crystallization. So we will see one by one what is the basic difference between the crystallization and distillation. Distillation, all of you must be knowing about it. And what is the benefit of the distillation? That the benefit of distillation is that we get both the things. Means the recovery is there of two substances, the dissolved solid and the liquid. So both are separated. This is the benefit of distillation. Dissolved solid is also separated and the liquid is also separated, the distillation process. And what is the benefit of crystallization? By crystallization we are able to get the substances or the dissolved substances in its pure form. Means we can obtain pure substances by the process of crystallization. In your book also there are so many examples given. For example, seawater contains salt, it is saline in taste because it contains salt, dissolved salts. So it is separated. It contains so many impurities apart from that also. So but the process of crystallization helps us to get the pure salt, the salt in its pure form and leaving the impurities there. Now crystallization, for crystallization we must know about solution. All of you know solute plus solvent is solution. Then you must know about saturated solution, supersaturated solution, and because from saturated solution or supersaturated solution, both from saturated solution we can also get crystals, and from supersaturated solution. So what is saturated solution though, that I will tell you. So let us first discuss. I would like to show you the concept map which is given in the book. I have drawn it, and then I will show the distillation process, and then we will go for the crystallization process. So let's start. So we were discussing about solid liquid mixtures. So this is the concept map. I have drawn this because it is in your book. So a little explanation will let you to understand it in a rapid manner. So see, we have two cases when the solid is insoluble in the liquid. So we have dealt with this solid-solid mixture separation. So when the solid is insoluble in the liquid, the sedimentation and decantation, loading, filtration. These all we have discussed. Case 2, when the solid is soluble in the liquid. When the solid is soluble in the liquid, so evaporation, crystallization and distillation. Evaporation, we get only the solid. We have seen evaporation, we heat it and we get the liquid part is vaporized, and the condition is that the solid should be non-volatile. That is very important, dear students. I have told you earlier also. Then today we are going to deal with crystallization and distillation. So in distillation, what is the benefit of distillation? In distillation we get both the solid and the liquid part. Both we are obtaining. The recovery is of both the substances, the solid part and the liquid part. And it's a very simple process. So let us see the diagram. With the help of diagram we will see the distillation process. So you can see dear students, you can see the apparatus, the arrangement of the apparatus for the process of distillation. So here we have a round flask, wire gauge, tripod stand, Bunsen burner, and in this flask or the vessel we have the salt solution. We have the salt solution, or you can say we have the mixture which is to be separated, which contains the soluble salt and water. or the liquid, whatever you say. Then we have the thermometer. Then this is connected to this reverse condenser. Reverse condenser is used to pass the steam or the vapors of this liquid, and this is connected to tap. So, and it is in the round, it is all around it, so that water flows through this part, so that the steam or the vapors of the liquid which is passed through it get condenses, and by droplets will collect here, and it will collect in a conical flask. So this is the apparatus, this is the conical flask to collect the liquid, or more commonly it is known as the distillate, and the solid part will be collected here as the residue. So we will be getting, after the process of distillation, we will be getting the solid part here and the liquid part here. Now it is very much understandable to all of you. Now why is this thermometer being inserted here? So the thermometer is being inserted here because if we are knowing that the liquid is water, so that we have to provide that much temperature only on which this liquid changes to its vapor form. And if suppose if it is water, so the temperature should be maintained up to 100 degree. So we don't waste our energy or whatever the supply or the source through which we are providing the heat energy, and the arrangement will also be not disturbed. If we provide extra heat energy, it may get spurted or like that. So this thermometer is to measure the temperature of this liquid which is changing into vapor. If it is water, then steam. So to maintain the temperature, this is used. So this is the complete arrangement of distillation. So we are getting by distillation the solid separately as the residue and the liquid as the distillate. Now let us go for the process of crystallization. Now dear students, to understand the process of crystallization, we must know about solution and solute and solvent. So what is a solution? Any solid is being dissolved in any medium, say any liquid, or say most commonly water. It can be many mediums, but at your level I am just dealing with the liquid and the solid particles. So it is being dissolved and you stir it. Suppose you take salt, suppose you take sugar in a liquid, in water, you dissolve, you stir it. So what will happen? It will get dissolved. So the dissolved part, the complete part, that is known as the solution. So the sugar or the salt which is being dissolved in it, it is known as the solute. And the liquid or the water in which it is dissolved, it is being dissolved, that is solvent. So solute and solvent together constitutes a solution. So here we have, suppose that this is we have liquid, or commonly say water. So this liquid and here we are adding some sugar particles or sand particles, suppose. So when we are adding, so the part which is added, it is known as the solute. In which it is added, it is solvent. And so dear students, this solute plus solvent together constitutes a solution. This is known as the solution. So generally solute is in lesser amount than solvent, generally and practically. Solute is in lesser amount than solvent. Now when this solute is being dissolved in it and you go on adding more solute, suppose for example you go on adding more sugar or sand and you stir it, so it will be dissolved, but a stage will come that no more solute can be added to it. एक स्टेज ऐसा आएगा, मिलाते जाओगे तो स्टिर करने पे भी, मिक्स करने पे भी वो मिक्स नहीं होगा, तो दैट स्टेज नोन एज सैचुरेशन. So no more solute can be added. So the maximum amount of solute that can be added to a solvent. So when we reach that condition, that is known as saturated solution. So For crystallization, this saturated condition is very, very necessary. Now we have a saturated solution. Now we want to add more solute in it. So what we will do? We will heat it. We will raise the temperature. So what will happen? Raising the temperature will tend to increase the intermolecular spaces of the solvent particles. So more solute can be added. More solute can be added by increasing the temperature. So this way, and when what happens in the crystallization, listen to me carefully. Now you have a saturated solution and you heat it. So no more solute can be added in. So the solution, that system is now fixed with more amount of solute. It is enriched with more amount of solute and it is in a hot condition. Means you have raised the temperature to increase the more solute in it. Now when you will allow to cool it, what will happen? See, this, there is the intermolecular space. The intermolecular space of the solvent particles. You raise the temperature, this intermolecular space has increased, so more solute has been added. Now when you will cool it, listen properly, when you will cool it, so this intermolecular space will contract. So when it will contract, तो जो इसके बीच में solid particles थे, the solid particles which were inside the intermolecular, they will come out in the form of crystals. So this process is known as crystallization. Again I am repeating, you have made a saturated solution by adding more solute, then you increase the temperature, intermolecular. तो जो एक नॉर्मल सी बात है वो भी मैं बता दे रहा हूँ, जो डिसॉल्व होता है वो सॉल्यूट जा कर रहा है, it is taking the intermolecular spaces of the solvent. So that is known as the dissolution. So when you increase the temperature, saturated solution प्राप्त कर लिए, you have reached a saturated solution, you have obtained a saturated solution. Now in order to have the process of crystallization, you heat it. This will enable more solute to be added in it. How? Because it will increase the space. The space will increase. Why? Because the intermolecular space will increase. But when you will allow to cool it, again this intermolecular space will contract. The space will decrease. So, the solid particles which are there in the intermolecular space, they will come out in the form of crystals. So this process is known as crystallization. In layman's language, इस इंटरमॉलिक्यूलर स्पेस में जो फंसे हुए थे सॉलिड पार्टिकल्स, जब ये इंटरमॉलिक्यूलर स्पेस कम हुआ तो क्रिस्टल्स बाहर आने लगे. सो दिस प्रोसेस नोन एज क्रिस्टलाइजेशन. आई होप नाउ यू अंडरस्टूड इट. सो व्हाट इज द बेनिफिट? वी कैन गेट प्योर dissolved substances by the process of crystallization, because the impurities, they do not crystallize. So because each and every substance has a unique property to crystallize at a particular temperature, and their saturated solution, only they will crystallize whose saturated solution is being formed. So this is the process of crystallization and you get pure substances. So that's all about today's lecture, distillation and crystallization. In the next session, we will start a new topic. And so that's all for today, dear students. Thank you very much.